Hi everyone, welcome to our final week of assignments. This is our final week together. This is week 11, and this whole week is going to focus on volume of solids. So 12.4, we're going to focus just on the volume of prisms and cylinders. So a lot of this you can read through. I'm just going to add in a couple little notes here and there. So I think you all already know that the volume of a solid is the number of cubic units of space contained by the solid. So here this would be a linear unit because it's one dimension. This would be a square unit, it's two dimensions, and then a cubic unit is three dimensions. So if I was to take a bunch of these cubic units and stack them together, they would form a solid, and then all of them combined together would create your volume. So let me just show you a little bit more what I mean by that. So here we have one cubic unit, because there's length, width, and height. And so I just want to show you that when we're talking about a prism, if we increase the height and then increase the width, and then if we find the area of this and multiply it by the length, we will get the total volume of a rectangular solid. Okay, so now I think we understand how the volume of a rectangular prism is probably going to work. So the volume of a rectangular prism is length times width times height. So my rectangular prism that I have right here has a length, a width, and then if I turn it, it has a height. So if I multiply those three dimensions together, I will get its volume. Now I can actually simplify this formula a little bit more. Instead of doing length times width times height, I can do base times height. So this capital B stands for the area of the base. So this rectangular prism that I have right here, if I find the area of this square base right here, and then multiply by the height, I'm really doing length times width times height. Now, why are we simplifying to base times height? Well, not only does this work for a rectangular prism, but the formula base times height can be used for any type of prism. So let me show you where that comes from. So I really like this GeoGebra visual because it explains how the volume for any type of prism will always be the base area times the height. So if you look, right now I have a triangular prism. I can manipulate the height if I want to, so I can maybe give it a height of 3. And then you'll see down here, it's giving me the area of the base as well as the volume of the base. And no matter how I change the base of this prism, the volume divided by the area will always equal the height. So let's see how that works. So if I take this and create a pentagonal prism, even though the area of the base and the volume have changed, when you divide them, you still get 3, which is your height. And I can do that with a hexagon, heptagon, octagon, no matter what, it'll always be proportional and the height will not change. So that is why I like this visual, because it shows how the relationship between the base and the height create the volume formula for a prism. So now that we understand where the volume of a prism comes from, let's talk about the volume of a cylinder. A cylinder also has the formula base area times height. However, we know that the base of any cylinder is always going to be a circle. So we can actually simplify the formula to pi r squared, because that represents the area of a circle, times height. So that's how we're going to find the volume of prisms and cylinders. Now, all prisms and cylinders have a cross section. So if you remember from last week's video, I showed you, if you watch my GeoGebra video, how you can see the cross section, or basically like a slice of a prism or any type of solid. So there's one more formula that you're going to see in your homework, and it is this one. The volume of a prism or a cylinder is equal to the product of the figure's cross-sectional area times its height. What does that mean? Let's say I know the area of one cross-section of a cylinder. So here's my cylinder, here's my sliver in the middle of the cylinder, and that's my cross-section. And this C with a line through it is to represent the area of that cross-section. Since that cross-section is is really, it's just it's going to be equal to my base areas. If I multiply that by the height, I should still be able to get the volume of the cylinder. And this works for prisms as well. So let's do a couple practice problems using these formulas. So let's start with a nice easy one. Find the volume of the rectangular prism. So you can either use length times width times height, which is what you're used to, or you can use your base area times height formula. So I colored in my bases. It's that 20 by 5 rectangle, and I found the area to be 100. The 15 is my height. So if I multiply 100 by 15, I will get a total area of 1,500 for this rectangular prism. And there's no units, so I don't have to include units right now. But if I was going to include units, it would be units cubed. So remember, when we're doing perimeter, it's just the unit. Area is units squared. And when we're doing volume, it's units cubed. So now see if you could find the volume of the triangular prism in number 2. So before I can plug into my volume equals base area times height formula, I first need to figure out what the area of the base is. So I redrew the bases that I have here, which are triangles, and you can see that they're isosceles. So what I ended up doing is I ended up drawing in the altitude. It's also the median of that triangle, and it bisects the base into 2 equal pieces, so 6 and 6. Then I have this right triangle. So I could do the Pythagorean theorem, h squared plus 6 squared equals 10 squared, in order to find h, or if you know your Pythagorean triples, this is really a 3, 4, 5 in disguise. So h is going to be a length of 8. So my area of my base is going to be 1/2 times my base, which is 12, times my height, which is 8, and that will give me 48 units squared, because that's area. And now I can plug into my formula. So my volume equals the area of my base, which is 48, times my height. My height is going to be this 15 right here. So I know it's laying on this bottom piece, but remember, when you have a prism, it's the 2 parallel shapes that are the bases, and then the rectangles are what involve the height. So the height here is going to be 15. So I have to do 48 times 15, and I will get 720 units cubed as my volume. Okay, so now let's look at a cylinder. So we are going to find the volume of a cylinder with a diameter of 6 and a height of 12. So if my diameter is 6, my radius must be 3, and I have my height of 12. So remember we said, for the volume of a cylinder, it's like we're taking the area of the circle and stacking it up as high as the height is. So we're using pi r squared h. So we're going to do pi 3 squared times our height. And if we leave our answer in terms of pi, we'll get 108 pi. But you could always round it as well. So 108 pi units cubed. Okay, so now we're going to look at number 4. We're going to find the volume of the right prism shown. So that just means that there's all these right angles where the vertices meet. So there's 2 different ways to do this. So I'm going to leave it up to you to figure out how to find the volume. Okay, so here's your 2 options. Method 1, divide and conquer. Divide this up into 2 shapes that you know, so 2 rectangular prisms. Find the volume of each. So the volume of this top one will be 100. The volume of the bottom one will be 280. And then add them up to get 380 units cubed. There's another method. So there was that final formula on the bottom of your note sheet, which was volume is equal to the cross-sectional area of the solid times height. So I drew the cross-section of this shape, and if I can find the area of this and multiply it by the height of 10, I should also get 380. So let's see. If I divide this up again into 2 shapes I know, I'll have an area of 10 for that top piece and an area of 28 for the bottom piece, which means the total area of this cross-section is going to be 38. So if I use the formula, C with the slash through it times H, I'll say the area of the cross-section is 38 times my height. My height will be this 10, because if I set the figure on this bottom piece, it'll be 10 high. And 38 times 10 is 380. So both methods work for a composite solid such as this. So now in the next video, we're going to learn how to find the volume of pyramids and cones.